Okay, this is part 2 of working some additional problems with our logarithm unit where we are applying the logarithm theorems. So, I should say the lesson where we're applying the logarithm theorem. So number 9 here, we are asked to evaluate. So when we evaluate, we need to end with a numerical answer. So we've got a lot going on up here in this exponent location. We have a base of e here. So what I'm going to do first is combine this exponent here using my logarithm theorems. So I will have e to the ln of 7, not changing anything there, plus ln of 5 cubed. So what I did there, I took this 3 multiplier and moved it up as an exponent. And that is applying this theorem right here. Next, I've got an addition of 2 logarithms. I'm going to condense those into 1 logarithm through multiplication. So 7 times 5 cubed, the natural logarithm of that quantity. And 5 cubed is 125. So I have e to the ln of 7 times 125. And coming up here, do another color to keep our steps separate. So we'll have e to the ln, this is a multiply right here, not a decimal. 7 times 125, if you work that out, is 875. So I have e raised to the power of ln of 875. Okay, and now we have this property right here going on. We have a base of e, right? Let's do it here. We have a base of e for our exponent, and within the exponent, the logarithm that's included also has a base of e. Remember, ln is the same thing as log base e, and so now we have a base of e for the exponent, we have a base of e for the logarithm, so those are going to cancel, and we're just left with the part that's right here, and that's the answer. So our answer here, finally, is 875. That's the answer to number 9. Okay, let's move on to the next one. Here we are with number 11. So on number 11, they want us to rewrite this, basically simplify it down to a single logarithm. So right now, notice we have 1/3 times this logarithm plus this logarithm. So we want to condense that down, simplify it down into a single logarithm. So we want to start applying our condensing theorems to break this down. So we want to condense them, so we want them to look like this. Right now they're split into pieces. We want to break them down so that they look like this. So the first thing I'm going to do is make this log base 3 of 27 to the 1/3 power. I'm applying the theorem that says a multiplier in the front can be brought up, can be condensed in to be the exponent. So that's what I've done here. So that would be this theorem right here. And then plus log base 3 of 4. So now 27 to the 1/3, we can go ahead and evaluate that. Remember, the 1/3 power is just the cubed root, so I could rewrite it this way. Log base 3 of the cubed root of 27 plus log base 3 of 4. Well, the cubed root of 27 is just 3, so log base 3 of 3 plus log base 3 of 4. So now I can condense this. It's addition, so I can condense it through by using multiplication. So then our final answer here is going to be log base 3 of 3 times 4. This is the final answer, but let's simplify it one more time. Finally, log base 3 of 12. 3 times 4 is 12. So now it's one single logarithm, and it is equivalent to what we started with in the beginning. So log base 3 of 12 is the answer on 11. Okay, one more. We'll do number 14 from your homework. All right, number 14, that'll be the last one for this video. So we are asked again to condense this down into a single logarithm. So we have a logarithm here, we have a logarithm here, we have a logarithm here. So we want to condense that down into one. So we're going to start applying our theorems over here to condense it. So we have a -2 multiplier in the front, so I'm going to go ahead and bring that up as an exponent here. That's applying this theorem right here So it would become ln of pi raised to the negative 2 power, that's the argument there, plus ln of pi cubed, the argument there is pi cubed, plus, and I'm going to go ahead and work with this one. So this 2 multiplier, I'm bringing it up as an exponent, so ln of r squared. So all I did, the 2 multiplier in the front came up as the exponent. That's what this is coming from right there. And that is, again, applying this theorem. So now I have all additions going on here. So that I can combine all of them, and I can actually do it in one step. I can go ahead and do that. And they're addition, so I can combine them, condense them through multiplication. So it'll become ln of all of this, pi to the negative 2 power times pi cubed times r squared. Now I need to simplify a little bit in here. I have a pi, the same base here. I have a base of pi in both cases. So negative, I'm adding the exponents here, adding the exponents. Negative 2 plus 3 is 1, so it's ln of pi to the first power, we won't write it, and then r squared. So that is our final answer right there, ln of pi r squared. Now another way, right here at this step, I'm just going to show you another way to do that. So right here, I could have rewritten that as 1 over pi squared, because I could apply the negative exponent rule. I have a negative exponent rule, it's over 1 right now, so I can take it to the denominator and make its exponent positive. So right here then, I would have this is going to, we'll end with the same thing, ln of 1 over pi squared times pi cubed times r squared. Well, if you put the pi cubed above right here, we have, this is over 1. Well then, if you have pi cubed over pi squared, you're just left with pi, so ln of pi, and then you still have the r squared. So either way, you get the same answer, however you want to handle it. And that is it for this lesson, and that's it for this video.